Okay. I actually work as a programmer. I work for Fabric.com. We sell clothing. It's an Amazon subsidiary, so it is fun. And I'm actually working right now on the warehouse system. So the guys who are actually cutting the clothing and all of that stuff, we are controlling that stuff. So it's a fun thing. Sorry?
So hopefully we'll get to that point.
Stick with it. You will. You definitely will. It's been the I've been here for about 20 years. I came here in 95, so yeah, basically 20 years. Even when the market sucks, it doesn't suck. I mean, it's been a very, very nice career from a kind of money and career perspective. Plus, this is what I like to do, so it is a lot of fun. But if you get into it, the programming, right? Every day you are kind of solving problems, right? And so almost every day you get the woohoo! I achieved something. I solved a problem today. And normally you get a big rush, right? It's like, okay, woohoo! I did it. I'm the man. So that kind of stuff you get it every day, which is really cool. Any other careers, I don't think you do that. But anyway, let me do.
What's the username and password for the Wi-Fi?
I think
It's your school user, like your ID, and then your password for your ID.
Gotcha. Okay.
unless you use case you guessed, and that one is just Kennesaw.
Location guess it's a Kennesaw. Yeah, that's the password. Password. Yes.
Should.
Okay. Today, I want to go over slightly more complicated ifs and kind of go over ifs again. And one other important thing, kind of encapsulation and abstraction. And then we'll go do more recursion stuff, which is probably the hard topic, right? Probably ifs are easy, recursion is harder. So imagine that we are going to do a function or a method, right? Public static int max2 int and 1. We're going to return the biggest one out of those two. What do we do?
We compare both.
Okay. How do we compare both? That's good.
N1 is greater than N2.
Then what do we do?
And we return biggest one is N2.
Wait, we're returning an int. We don't return biggest one.
Print.
We are not printing, we are returning. Right? Normally, your functions should never print. Only main prints, or only most of your functions just return. For this class, it's okay, and you normally print to see what the heck you did, and that's okay. But normally, your functions shouldn't be printing much, right? You just return values. So what do we return if n1 is greater than n2? Which one is biggest?
N2. Return N2.
N2, is n2 the bigger?
Oh, no. N1, I'm sorry. S, return N2.
Cool. What happens if they are equal?
Now we bring up the message.
Why
It's not
would
going to do
I?
We
anything.
won't do anything.
If they're equal, what would happen? Is this condition true? Is n1 greater than n2?
If it's not true,
It's not true.
It's not true. So what happens when that condition is not true?
it exits out of the if statement.
And it executes the else.
Else.
So if they're equal, we're returning n2. Is that the right thing?
No.
What should we return if they're equal?
Sure, because we asked for the biggest.
It doesn't matter, right? What's the biggest one, 3 or 3?
It's 3.
3.
Okay, then it doesn't terribly matter, right? We could have done it either way, right? If they are equal,
So we
it's the same value, so we can return either one of them.
Either one.
Yes. Does that make sense? Cool. Now, imagine biggest one of 3. What do?
We gotta do it twice.
We're gonna do what twice?
We gotta do it called if twice.
Okay,
First,
so
we have to do if n1 greater than n2, and then return n1 if else.
oh wait, we cannot just return n1, right? Because n1 may be greater than n2 but smaller than n3.
That's what we're going to do now. If else, right?
So wait, you mean another if inside, right? So you're doing nested ifs.
Yes,
That makes sense. If n1, and
and
just to not confuse myself, because here you start getting, here, if you don't do greater than or equal, your logic becomes trickier. Because maybe you end up returning the wrong one. Maybe. I confused myself. So let me do this. So if n1 greater than or equal to n3, what do we return?
so we return n1.
Otherwise, what do we return?
I know we gotta do if again.
Ah, that is true.
We have to compare
Repeat
it.
it.
Wait, do we need another if? We know that n1 is bigger than n2,
Right. Well, how
and we know that n1 is not bigger than n3, right? So n3 is bigger than n2, than n1,
okay.
right? So which one is the biggest one?
So now we should return
N1.
n1.
Wait. Okay, we are here. Can n1 be the biggest one?
No.
Right? No, because it's not bigger than n3.
Right.
Can n2 be the biggest one?
No.
No, because it's not bigger than n1. So who has to be the biggest one?
It's n1 between n1 and n. Oh, n3.
Does this make sense? Yes, no, maybe. Close enough.
Yeah.
Does this make sense? Now we
N1 was a variable that represented something else. You know, and N2 is a variable. Well, I guess
like if they were classes or something, we'd be comparing them by something, right?
yeah.
You can we'd be comparing, if they were people, we'd be comparing their age. And so it is very similar, except that you compare age or whatever you used to compare. Or you end up defining your own method
Okay.
to compare. And you can do all the complicated logic you want. If they are the same age, then you sort alphabetically by last name or whatever the heck. But the logic of that comparison would be similar. You're just comparing what does this mean. You end up creating your own version of what does greater than or equal means. Now, we did if n1 is greater than or equal to n2. Now, that didn't happen. Right? So what do we, what happens now? N1 was not greater than or equal to N2, so who are battling for the biggest?
n2.
And who else? N2 and nobody else, so N2 won?
We already N2 and 3?
N2 and N3 are battling, right?
Yeah.
If N2 is greater than or equal to N3, what do we return? Right? It should work. Let's test, just not test, but let's verify, right? System.out.println. Let's do max2, which we actually never tested, right? 3 and 5. Now let's do 5 and 4 to verify that it works either way, and then 6 and 6. Right? What should we get? What do we expect to get as output? We're only doing up max2.
6.
So what's the first line going to print?
5.
5
5.
and 6. Yay, life is good, right? Now let's do max3. Let's do 3, 5, and 7. 5, 4, and let's do 2. 6, 6, 6. We haven't put the maximum in the middle, right? We will see later how to write unit tests, which is a better way of doing this stuff. But did we achieve what we wanted? Probably. Let's see. The first printed 7, which is the right thing, then 5, then 6, then 8, and 11. That is good, right? We sort of kind of achieved it, right? Do we like this code? Is it pretty? It has an incredibly good quality, right? What? It works, right? That's hey, it works. That's good. Now, is it pretty?
No.
No. Why not? What makes it not pretty?
So many if else.
Okay. It's getting slightly complicated, right? It's kind of long. One thing that I don't like about it is, are N1, N2, and N3 kind of equally important for the function? Yes. What happens to our code?
We can try to minimize.
In our code, they don't look equally important, right? N3 is being returned twice. Ooh, does that mean that N3 is more important? Does it have more chances? Right? No, it doesn't, because we did the logic right. But it just looks like N3 is somehow more important. Does that make sense? What could we do to have a structure where we return each one of them only once? We can't use switch, because switch doesn't let you do comparisons. Switch only lets you do values, right? But what we can do is, or it would be a pain to do switch. You can probably use sign or something like that and do switch, but it would be a pain. What we can do is use chained ifs instead of nested. Does that make sense? So we could do we call it max3C. Actually, let me call this one max3N so that we don't have to change our tests. And so I'm going to do on the first thing, compare, are you greater than n2 and greater than or equal than n3, then you return n1, right? Then else, and I need to be, else if n2 greater than or equal to n1 and 2 greater than or equal to n3, return n2. Else return n3, right? Does it make sense? Does it look prettier? Run it again and verify that we didn't mess it up by making it pretty.
It's less lines of code, right? Does that matter how fast it executes?
No,
No. Okay.
no. But it does sort of kinda matter at a very, very first approximation, and definitely not true, matters to how fast you can read it. Keep in mind, right? You're going to be modifying this thing, right? There was one of the famous guys said, like, programming is telling other people what you want the computer to do and only incidentally telling the computer what you want it to do, right? So it's like somebody else is going to be reading this stuff, right? And so it's not true. Reading 5 lines of, I don't know, what would be 5 lines of The Cat in the Hat is not the same as reading 5 lines of the Ulysses by James Joyce, right? So line numbers are number of lines is not a great measure for how complicated a program is. But reading 5 lines of The Cat in the Hat is harder than reading 3 lines of The Cat in the Hat, right? So they're the same complexity. Number of lines is kind of a slight approximation to how complex a thing is. It's not true, but it's better than nothing. When you get to software engineering, you get to talk about productivity and things like that. One of the standard dumb things that non-technical managers try to do is measure programming productivity by number of lines, right? And there's a famous Apple guy who, when they started doing that, he wrote minus 5,000 lines on a day or in a week or something like that. He simplified something that was horrible and had oodles of lines and kind of simplified it and make it work faster and better and more elegant by taking away stuff. So it's like, okay, how many lines of code did you write this week? Minus 5,000. They stopped counting his lines at least. It's not a great measure, but does it look prettier? Well, yes, but the lines are a little bit more complicated, right? So is it pretty? I don't know. You get to decide whether you like it better or not. Is this? It's not there. Just mine. Right? Now we have ants. Now, actually, do this so it stops whining. How easy or hard would it be to write something like this? That's 4.
Return 0.
No, not return 0. The right thing.
We have to do the same thing.
Yes.
Add an N4 up there.
Exactly. N1 and N2, N1.
Okay, we could actually do this, right? And well, let's try from here.
have to add one more escape.
What do we do?
And then we're gonna do N
3
and 4.
greater than or equal to N4? Is that all we need?
Oh, no, let's see. N1 and N2.
That's correct.
All right, N1. We means N.
Would this be okay? If N1 is greater than N2, N2 and then N3,
That would be
are we done? Who could still beat me?
N4.
N4, right? So what do we need to do?
Yeah, N1 greater equals N4.
Do it again. Okay. N1 greater than or equal to N4, yeah.
So in one P, we can add too many N.
As many as you want. The compiler, you will get tired way before the compiler does. There is usually a physical limit, right? I mean, eventually you write more ANDs than the amount of RAM you have or something like that. But chances are the computer has a heck of a lot more RAM than you can write ANDs. Your fingers will fall off your hand before you write enough. Yep.
That's what we're doing for math 4. For example, if somebody asks a program to compare like 20 numbers, we don't have to go to 20.
We will see arrays. Arrays allow us to do just bunches of things, kind of, and we can access each individual thing as the first thing, the second thing, the third thing, and then we can have the length, and so we know how many. But that's in a couple of weeks. But it's good, yes, that is. So here we need to do all the things, right? N3 greater than or equal N1.
It's equal.
Does this make sense? It is okay. It sort of kind of works, right? You can write if statements. There's a much better way of writing this. Let me do it first. Let me leave this one. Let me do it first with this one, right? It is chained. Imagine we have max 2, right? That gets us the maximum of N1 and N2. If we do that, right, how do we know the maximum of N1, N2, and N3? This M
Is M12? Is it just a variable?
just a variable name. M12 is the biggest one between 1 and 2. It's M1, 2. It's the biggest one between M1 and M2, right? So now, what can I do with that one?
So how do you know which one is bigger?
Well, I know which one is the biggest between 1 and 2. Now, am I dumb? I need to compare that one with whom?
Maybe 3 and 4.
Well, this is just max 3, so it's only 3.
Just 3.
So what can I do now? This should be n, right? Sorry, I'm an idiot. Maybe it was m for max, but that's okay. How can I get the maximum of those? The biggest one of those two? Wouldn't it be cool if I had a function that tells me the biggest one of two numbers? Do we have it?
make it.
What did we call above?
Max2.
Yes, what does it do? What does max2 do?
Compare 1 and 2 to 1 and 2.
Gives me the biggest one of two numbers, right? So I can just do Isn't this cool? Which one do you like better?
This is confusing.
Is it confusing?
No.
So you're using max2 function
Yes.
inside of max3 function.
Yes. And that's perfectly okay, right? I can call it from whatever.
So we got N1 and 2, max 2. We compare those two first, 1 and 2. Then we'll return the maximum number between.
Those two entry.
And then we compare that to the N3.
Yes.
Oh, I see.
And that's what we are returning. We could have put a variable, or we could just do this. And does this make sense?
Now there's no condition.
Well, the condition is really embedded in max2, but we don't care. Why do we need a condition? Isn't this cool? Doesn't that make our life nicer? It's again, right, the number of lines, right? This is maybe a lot less lines, but a lot. We pack more punch into one line, right?
Can you run it?
We can actually. We had the test for max3, right? So that should just work. We should get 7, 5, 6, 8, 11, right? Yay!
No, we do max 3. You are running max 4 now.
No, we're still running max3.
The max 3 have only three numbers.
Yes, that's the one that we did here. So we can convert this one into max4C for chain and write max4 using max2. What do we do? Who do we compare first?
And 1 and 2.
And who do we?
And then 2 and 3.
We could do.
We take max 2 and 3.
What about we do like a tournament? 1 and 2, and then
3 and 4.
3 and 4, and then the winner's battle, right? Yay! Isn't this cool?
Oh, we need one more, right, to compare both.
That's this one, the first max2.
Okay.
Right? This guy is comparing the winner of this and the winner of this. Does that make sense? Cool thing about abstraction. Which one would you rather write? Which one would you rather debug? When you're this is something that you kind of get as you go, but when you are writing software, you need to keep two things in mind. One is, have I done something simple that I can build into this, right? Or can I build something simple? How hard is it to build Max 2? Simple or hard? Max 2 is super simple, right? And then this is super simple. And so by figuring out how to combine the simple things and how to build simple things, ideally, you can make your job so simple that even you can do it, right? That's the idea, right? It's like, oh, I want something, I want to make this stuff so simple that I can do it on Monday mornings. I can do it on Friday afternoons when I'm looking forward to going home, right? And so this is kind of one of those things that you need to keep. But as you are starting your programming journey, as you go, try to see if you can do those kinds of things. Try to see if you can simplify and build simple steps so that every step is simple. We'll probably see like nested loops and things like that. Most of the time, when you have 7 levels of nesting ifs, it is cool that you can keep them in your mind, but it's probably wrong. There's probably a much easier way to do it. And that's why I did functional abstraction first, because that allows you to simplify almost everything. So most of this stuff becomes really, really simple. Does that make sense? Cool. Now let's talk about recursion, which actually combines this kind of functional abstraction, right? In fact, let's do kind of a super simple recursion first, and then we'll start doing complicated stuff, right? Super simple. Let's repeat power. How does recursion work? What do? We normally check if we are done. We return a base case. We return something where we know the answer. If not, we call ourselves with a slightly easier problem. Does that make sense? So, if the exponent less than or equal to 0, and the less than is just my paranoia, because if not, we end up with infinite recursion. What do we return? What's something raised to the 0th power? 1. That is good. Else, what do we return? We have, sorry? So what do we return? If you have 5 to the 4th power, how can you make it slightly simpler?
You got base. What's up, base?
Yep, return base times what? What is raising something to a power? It's doing a bunch of what? Repeated what? But what am I repeating n times?
The base.
The base.
But what am I doing with it? My
Minus 1.
sorry?
Okay, so it's on
I'm
base.
multiplying, right?
Multiply by base minus 1.
Base times, not base minus 1, but power of base exponent minus 1. Does this make sense? Does this basic idea of recursion make sense? Close enough? Close enough that you cannot ask any questions? Okay. If you remember, maybe they torture you. I don't know what they do in the US. Mathematical induction. It is a very similar idea. But it's also kind of simplification that we do, right? If you can have a problem, I'll do the first step, right? And I'll worry about the rest later, right? And then I'll do the next step and don't look at everything. Just do one at a time, and eventually you get there, right? Shall we do another one? What's going on with my... Let's just print for fun. We need to do public static, right? And we cannot access from main. How much is 5 to the 4th power? 625 sounds reasonable. Yeah, it is. Now, let's do something. We are gonna I know, import scanner from this guy. This scanner, yes. Life is good. Imagine that we're going to read and keep adding until we read the number 0, and then we return this sum. Does that make sense? So what do? We need to read a number, right? What do we want to call it our number? What do we want to call our number? What do we want to call our variable?
Num1.
Num1 sounds good to me. How do we read a number from the keyboard if we have a scanner?
Next.
Yep. F is good. We have read our number, right? And what do? How do we know if we are done?
Are we going to tell them to enter a number?
We probably should tell them to enter a number, right?
Yeah.
You are a UX guy, okay. We read the number, right? How do we know that we should be done? How does the user tell us that it doesn't want to enter any more numbers? What number do they enter?
-1?
Well,
No, 0.
Oh, 0.
we said 0, right? We could have chosen whatever, right? But let's choose 0, right? So they can put negative numbers in if they want. So if that number is 0, what's the sum of the numbers we just read in this function? We just read one number, it was 0, so what's its sum? 0. Life is good. What do we need to do? It wasn't 0. What do we need to do? Add this number with whatever the user is going to type next, right? How can we get whatever the user is going to type next until it types 0 and get the sum of all those numbers? What's a function that does that? Do we have a function that reads numbers from the user until the user enters a 0 and returns the sum of those numbers?
A function that's already been created up there?
Maybe. A function. It's the one that we are defining, right? Does that make sense? We could do something like this. Read the rest of the numbers, right? Sum of rest, how about that? And then what do we return? We have this magical function that reads a bunch of other numbers, right, and returns the sum. So now what should we be returning?
The sum.
That sum, so we just return sum of rest? What happened to our num1? Did we do anything with it?
If no one is equal to
We read the number 5, right? Okay, we read number 5. We call read and add, and it returns 8. What should we return now? Should we return 8? Should we return 5? What should we return?
so fine again.
Okay, let me see. Imagine that you are doing read and add, okay? You get the number 5. Keep that number 5 in mind, right? You're next. You read the number 8. You're next. You read the number 0. What do you return? 0. And what do you return?
8.
8. And what do you return?
5.
Why 5? What's the sum of the numbers? What's the sum of 0, 8, and 5?
That's the number I call.
You could add 5, but what should you return? You're adding numbers, so what should you return?
13?
13, right? So-
Okay, so if he have 1 and he have 8, he will return 9.
Exactly.
Okay, I see.
Does it make sense? Shall we do it again? You read a 5. You read a 7. Now you call him who reads a 3. Now we call him who doesn't read a thing. we call him who reads a 0. So do you keep reading? No, you return. What do you return?
0.
What do you return?
He got eight, right?
He got a 3.
He got 3. He's been 3.
What did you return?
10.
Yeah. Right?
Yeah.
He was 5, but right, you're coming from him. He returned 3. So now you return 10. You return 15. Does that make sense? How do we write it here? What do we return? Sum of rest is whatever came from the other thing, right?
No more.
All of those numbers that the user enters is stored in sum of rest variable.
Eventually, they get returned. The sum of those numbers gets returned, right? The actual numbers never get stored, only the sums. Does this make sense?
Yeah.
Does this makes it easier than this? It's the exact same thing, right? But which one is easier to understand?
Yeah, I like the
The previous one? Usually, you shouldn't worry about efficiency at this level. Premature optimization is the root of all evil. Don't worry about efficiency because 99% of the time, what you think is going to be slow doesn't end up being slow. When you see data structures, you'll see order of n notation and that kind of stuff. So what you think is slow doesn't terribly matter. This kind of stuff adds a constant overhead, right? So this, first of all, compilers are really smart. Maybe they optimize this stuff and it's the exact same thing, right? But even if the compiler is not smart, you're creating one variable, right? So you may end up using 2 more bytes of memory, right? Which is like, God, 2 more cycles? Maybe it's like not even a millisecond, right? I mean, you do what? 1 gigahertz, so that's 1 billion operations per second. It's a picosecond or something like that. I don't even know what we call things that small, right? And so it doesn't matter. The JVM took 10 seconds to boot, right? Who the hell cares about 1 picosecond? Eventually, you end up producing stuff that is slow. And once you know that it's slow, then you optimize that particular thing. And you still don't care about picoseconds. You care about the operation that actually ends up taking 10 seconds. So don't worry too much. If you like it better this way, write it this way. Chances are that as you grow more familiar with programming, you'll write it the other way. But if you like it better this way, then life is good. Write it this way. What else can we do? Shall we complicate stuff? Oh, let's actually verify that this actually works. New scanner system building. Please enter a number 23. Please enter a number minus 23. 23, 0. Hey, this one was 23, right? Yes.
How many times you have to enter the numbers? Because we can specify that one in the program, right?
We never. It keeps reading until you enter a 0. We can run it again and start entering numbers. 1, and we count.
So we can change the program based on how many times we want it to stop.
1, 2, 3, 4, 5, 6, 7. When do we want to stop? Done. So we entered 7 numbers.
What's another way to do the main method there without putting new scanner system in, all that in the?
You can do scanner input equal new
Scanner system in.
and then you can actually do int sum equals read and
Which way do you see it done most often?
it depends. Let me tell you. Sum is 6. Okay, that's right. I should have added a space, but a lot of times it depends on how complicated those things are and how comfortable you are with the idea of functions calling functions calling functions. Probably you guys should be writing it more like this. But I want you guys to get as much familiar with calling as you can.
So that's what the first example was of the system.out.print. That's a function itself, right?
System.out.println is a method call. Yes.
It's a method. Same thing as a function.
Yes. Yes.
But what show if you have system.out.print without a print line?
Sorry?
If you miss the line.
If I miss the line?
Yeah.
What do you mean?
System.out.print.
If just call system.out.println?
No, not just print. Not without line.
Oh, without the ln, it's almost the same thing, except that it doesn't print a new line. Basically, if we print something else after, right? Run this, we get 1, 2, 3, 0. We get the sum is 6, and then that's all, folks. If we don't put the print line here, we just put print, and we run it again. We get that's all, folks, on the same line, which, yeah.
Can you use a like a /n like in C++?
You can.
Same thing.
You probably can. Except that it's not readable, plus it's officially not right.
Really? It was.
Well, it works on this machine, right? Basically, every operating system is free to define what the heck does it expect, or every terminal is free to define what the heck does it expect for it to move to the next line. And so every sane operating system uses /n, but some of them don't. In fact, I can't remember which one is which. Unix uses one character and Windows uses another. Like, I think Unix uses /r/n and Windows doesn't. Windows only uses /n. So on Unix, if you do /n, it just moves a new line. And some of you are old enough, please tell me some of you are old enough to have used a typewriter, an actual typewriter, not a computer, right? I don't know if you remember, there was a tiny lever here that will make the thing rotate. That's the new line, right? But it wasn't a carriage return. If you pressed it, you could also return the carriage, right? But those were two separate operations. This is the same idea. /n is new line, go to the next line, but not necessarily go to the beginning of the next line. It's just go to the next line. So in some operating systems, you would see that's all folks starting from the column where the 6 is at. So you would see something like this.
And the T is for tab, right?
Yes. So you would see something like this. Right?
So we shouldn't even use that in like C++ or anything.
You are not supposed to. You're supposed to use endl,
Yeah.
right?
Oh,
And
no.
endl is supposed to do the right thing for your operating system.
Yeah.
And so if somebody comes up with a new operating system that uses Unicode 57 for new line, right? /n wouldn't work, but the other thing would.
Okay. So that just tells the compiler for the operating system, take the correct here.
Yes.
Okay.
It's a library function, so whoever writes the library for your operating system inserts the right character there. For the most part, yeah, it just works. But there is no particular reason to do it, given that you get the right one. Why would you do it wrong? Unless you're writing to a file, and then what you actually want is to control which character gets written. And then I want to put /n. It's my file. I define how it looks like. Does that make sense? It depends on what you're trying to do. But let me just, since we have 15 whole minutes. Woohoo! Let me show one other way of writing recursive functions, which is, or with factorial or power or whatever. Let me do it with, shall we do it with this read and add or with power? Let me do it with power. Using an accumulator. Pass the current total, right? And so here what we're going to return is the current total. And here what we're going to return is our base exponent -1 and what should be the current total. Does this make sense? So we just keep passing our current total. In certain languages and with certain compilers and things like that, this would end up being a faster implementation. It would basically be a loop, but it's the compiler's problem, not yours. And if not, it can give you just another way to looking at how can I do it when I have to do it. What's the problem with this one? We end up with an extra thing. So if we were calling this, we need to pass there 1, right? So we could write a wrapper that passes a 1 and things like that. Does that idea make sense? Now let me do a couple of other interesting things. Let me do this just to keep this as a sample of how you would call it. We are going to start thinking about something that looks like a race. We're not going to look at a race yet, but we have a string, right? String word equals the. That's a word, right? We can do this. We have the car at method. What would that return? What's the character in the position 0 of that string?
T.
Capital T, right? Does that make sense? If we do 1, what would we get? If we do 2, right? So we can actually do, let me do this. Let me print it. System.out. Die, you thingy. Don't autocomplete. I'm telling you what to do. So that's one thing that we can do with strings. And another thing we can do is what would that print? 3, right? Does that make sense? So let's run it and verify that I didn't lie to you. Life is good, right? Cool. So let's do interesting things with strings and recursion. We're going to return how many A's does the string contain starting from that number from. Does that make sense? So if we call what would we expect to get? Let's see, what's the character number 3? 0, 1, 2, 3 is that second A. And we need to define, is it inclusive or exclusive? Let's define it inclusive, right? So that one counts. So we get 1, 2, 3. Does that make sense? Yes? We are using lowercase a, even though we are calling it capital A on the name of the method. So what if we have the same string and 0, what would we get? Did I put the same string now? Of course I did. A, B, C, A, B, C, A. Yes. 4. Does that make sense? How about what's the answer? how many A's are there from the character number 37 on that string? So how many A's? 0. Okay. Right? What's the lowest number where we know we can get 0 instead of 37? Let's see. 0, 1, 2, 3, 4, 5, 6, 7. So 8 would be the least, right? Does that make sense? So that gives us our code, right? When do we know that we are done and we can return 0?
I mean, if the number of A is
We don't care the number of A's, right? What do we care? That we are done with the string, right? So that number from has to be what? Greater than what? S dot blank, right? That's greater than or equal because we start at 0. That makes sense. So if it's greater than or equal than the length, then how many A's are there? How many A's?
0.
0, right? We need to do more things. If S dot car actually, let's do this. Else, you're probably gonna like it like this. So we're gonna do num ace int if the current character is an A, then num ace here is gonna be 1. Otherwise, it's gonna be 0. That makes sense. Now, how can we get the number of A's on the rest of the string? Wouldn't it be cool if we had a function that counted A's in a string? Do we have it? What's the name of that function? Number of A's, right? Which string do we want to count? Same string as. But now, where do we want to start counting? Not where we were, but where?
From 1.
The next guy, right? I just need to count from where I am at, right? So I'm going to call my little brother or sister and tell them, hey, you count from here on. I don't give a hoot how you do it. Just count from here on. So what do I pass? What do I do the next character? That makes sense. That guy is that guy's problem, not me. And then what do I return? Just the number of A's here? I need to return the number of A's from me on. So I need to add that, right? Oh, under. I'll try to make it public and static. What's the word that contains all the vowels? Okay. Abracadabra. That makes sense. And what do we expect to get? How many A's are here? 1, 2, 3, 4, 5, right? So if we didn't mess up, we get a 5. Woohoo! Is recursion cool or what? This defining the variables makes it easier to understand. Probably. But do you see the pattern here, right? We are always saying, okay, let me figure out what do I do for this case, right? Then the rest of the stuff, whatever the stuff is, and then combine my answer with the rest of the stuff and keep passing it up. Does that make sense? Yeah. Cool. Then I will see you guys in a weekish. Any questions? No.
That tax rate example, to put
Yeah.
it in Eclipse and to get it to work, you have to have a tester class, right?
I have a tester class. I give it to you in A3. You
Oh.
download the zip file. It has a tester class.
Oh, I didn't see it.
When you call grade,
Oh, okay, got you.
it's there. Yeah.
Gotcha, okay.
And call grade will grade. It will run tests.
And it'll run it.
Yes.
Okay.
We'll see later how to write those classes. But right now, you don't even know what classes are supposedly.
Don't need
Some
to-
of you do.
okay.
So we'll eventually get there. Politicians promise.
So if we just put the method, the tax rate for singles method in there and run it, it'll run.
You need to modify main and then run it.
Okay.
If you just write a method, it doesn't know what they want it to run.
Modify main within the same class.
Yes.
Okay.
And then you press run and it runs, like we have been doing here.
So really, all these are just packages that we're playing with. We haven't really been using classes.
We have been using one class, right? But all of our programs have only had one class, right? If you notice, the very beginning of every one of our examples, or not the very beginning, but at the very beginning-ish, we have public class something. But we haven't really been using classes. We have been doing this because Java forces you to use a class. So it's like, okay, Java, here's your effing class. In few weeks, we'll actually use this for good. We'll actually use classes for a good reason as opposed to because Java is annoying and wants us to use a class.
So if we have this in the same package, I guess, so that if we had this file, the same package as another file, and from that file you call lecture fab 8.max2, it would actually run.
Yes. Yes. And you wouldn't even need most of our stuff just to get you guys, and we'll see public means anybody can access it. So it doesn't even need to be in the same package or anything like that.
Okay, so as long as it's somewhere on your computer.
As long as it's somewhere in the same project, right?
Yeah, it's a project, yeah.
But it can be in a different folder in a different package, and you just use the same name. This is okaram.samples.lecture58, or import okaram.samples.lecture58, and then you can use it.
Yeah. Okay, so you have packages and then classes.
Yes. we will, I promise, we will actually see that stuff. But for now, I'm really, really happy if you guys understand functional abstraction and recursion, and this would be
I was
amazing.
reading the question to online, but they gave us two examples. One is the factorial, and the other one was triangle.
Yeah.
So I was kind of confused about the triangle one. Maybe we can, you know,
From the book?
Yeah.
Don't die. We are done with class, so if any of you needs to leave, I mean, you're all adults. If any of you guys need to leave, even in the middle of the class, feel free to leave. But I feel bad about taking extra time. So was it on this one or this one? This, right?
Those two even open.
God.
Those they don't even-
They changed.
they don't even open.
God. And you guys never told me. They published a new edition of the book, so all the links changed. And I did my links before that. So where is the triangle thingy that you're talking about?
On the good.
Countdown. This one, there's no triangles.
Oh, I don't know what I see. I know if it's on YouTube video or I don't know.
When you, I mean, probably the Sierpinski triangle. But if you, when you see it, post on the discussion, and we'll talk about it with something specific as opposed to the triangle thingy, because it depends on how you define it. But those are recursive curves. They actually make pretty pictures. Yeah. I will fix those links. You guys haven't been reading the book, right?
I tried a couple times, it won't open. So I was like, I just go to your YouTube video.
I just downloaded the PDF and just kind of went through there.
Okay, that's good. That's
Like
good.
read chapter 4. Okay, I'm just gonna chapter 1.
Just to add confusion, sorry, this guy adds a couple of chapters, so the chapters are not the same on the newer edition. We're using the 5th edition of the book, which was available when we started. There's now a newer edition of the book, and so I will make sure to use the right links now. Thanks for letting me know. And I will see you Monday, a week from today. Have a great Valentine's Day.
So far until Sunday, the only thing that's due is assignment 3, right? We don't have
Yes.
anything else to do.
No,
Okay.
no.
And so-
Assignment 3 is due Sunday.
And we're not turning in any of these examples from the extra or from the links and stuff.
No.
We're just doing okay. I just want to make sure, so we just turn in.
Hopefully you make them for understanding.
Yeah. I'm going.